Hey guys, how's it going? So we have Expo review today. So we'll be working a few of these problems out, and just hopefully it doesn't take us too long. Again, this is for your test tomorrow on exponents, and so we start with our exponent rules. So here on the exponent rules it says remember to expand it out. So remember that there's nothing wrong with you going in and expanding it out. The biggest mistakes that I see whenever students are multiplying or dividing is that they mix and match and they don't remember which rule is which. So we're just going to go ahead and start off by expanding some of these out, and then we'll talk a little bit more about the rules. So for the first one, we have negative 3x squared y to the third, and then in parentheses we have 4x y squared. So what I'm going to do first, I'm going to show you guys how to expand it out, which is always going to be your fallback in case you don't remember how to do something like this. So to expand this first one out, again, it's just negative 3. Then it's x squared, which means that I have two x's. Then it's going to be y to the third power, which again means that we have 3 y's. So that takes care of this first expression. The second expression, 4xy squared, means that I'm now multiplying by 4, then by x, and then I have 2 y's. Remember that I want to put them next to each other and not underneath. The reason that you don't want to put it underneath is because if you put it underneath, you're going to want to cross stuff out or cancel stuff out, and that's not what we're doing. Anytime that we multiply, we're going to multiply our exponents, which are our big numbers, and then we're going to count up our variables, which are our letters. All right, so we start with our numbers, and this you can do on your calculator if you want. That's going to be negative 3 times 4, which will give you 12, negative 12. And then basically all you do is just count your exponents, your variables, which is going to be 1, 2, 3. I have 3 x's, which I can smush back together into x to the third power. And then my y's, I have 1, 2, 3, 4, 5, for a total of 5 y's, so I can write that as y to the fifth. Expanding this out just a little bit more, or talking about our rules a little bit more. Anytime that you see a power or an exponent on the outside, what that means is that this is then going to be written twice. So I'm going to write this whole expression twice. So that's going to be 2xy to the third, 2xy to the third. So I'll multiply it twice. Here, if we want to follow our rules, we do our numbers. So we do 2 times 2, which is 4. X times x, which if we remember from our quadratic unit, it's going to be x squared. And then y to the third times y to the third. All I do is add my exponent, so it's going to be 3 plus 3, which gives me 6. For number 3, we have this whole expression here, 3x squared, y to the fifth to the 0 power. Anytime anything is raised to the 0 power, it doesn't matter what that is. So here this whole expression is raised to the 0 power. Anything to the 0 power is always going to be 1. Number 4, 48a squared b to the negative 4, 8a to the negative 5 b squared. There's multiple ways to do this. I'm going to show you how I would do it. What I would do first is I would fix my negative exponents. So we have this, and then we have this. The way that you fix your negative exponents is basically if they're on top, you're going to move them down to the bottom. If they're on the bottom, you are going to move them to the top. Hey, how's it going? Good. Basically, so we're going to move these exponents up. So I'm going to go ahead and rewrite it. A lot of students often forget to rewrite this. So it's always a good idea to rewrite this. So we start with what we never changed, so we never touch this. So I'm going to go ahead and rewrite it again. So we have 48a squared. And then this a to the negative 5 is moving up to the top. It's going to lose the negative. Whenever it moves from the bottom to the top, it loses the negative. So now we have a to the fifth. Down at the bottom, the two things that I didn't touch were b8 and b squared. And then the thing joining these two is going to be this one, b to the negative 4. Again, whenever I move it, it becomes b to the positive 4. All right, and now I can simplify my expression. You would type this into your calculator, and alpha y equals 48 divided by 8, which is going to give you 6. Since it's a whole number, I'm going to go ahead and put it on top of the fraction. Usually you would cancel stuff out or cross stuff out as you go, but here if we put a squared and a to the 5th, since they're both on top, we can just add these two exponents together. So 2 plus 5 is going to give me 7. Down at the bottom we have b to the b squared and then b to the 4th. Again, we add our two exponents again since they're on the same side of the fraction, and then make sure that you keep it on the right side. So this should be b to the 6th down at the bottom. So my solution here is 6a to the 7 divided by b to the 6. All right, number 5 is a little bit trickier.
Thank you. The viewers, please come to the front office. Thank you for the viewers.
Number 5 is a little trickier simply because we have two terms. So this term, and then we have this term. The tricky part about this term is that the second term is squared, so we have to make sure that we simplify this first. So on this side, this is just going to stay the same, 3xy to the 3rd power. This, however, I need to write twice, so that's going to be times negative 2x squared y times negative 2x squared y. All right, so from here, same thing. I multiply my coefficients. So I'm going to multiply 3 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. 4 times 3 is 12. And then we do the same thing. We have x technically to the 1st power, so it's going to be 1 plus 2 plus 2. Again, you have to make sure that you do all your variables first, all your x variables first. So we have 1 plus 2 plus 2, which is going to be x to the 5th. As far as my y's, I have 3 here, 1 here, and 1 here for, again, a total of 5. For number 6, we have a rectangle has an area of 75x to the 4 y squared and a length of 15x y squared. What is the width? Anytime that you're given area and a side, it's going to be a division problem. Put the area on top. And you put the side, whatever side is given, on the bottom. That helps you find the other side. Again, you do your coefficients or your big numbers, you do those on your calculator. So 75 divided by 5, which is going to give you 5. And again, we want to try to write this as a fraction just in case we need to. And then if you're going to follow your rules for exponents, you would do top, or different teachers do it different ways, but I always do top minus bottom, so 4 minus the bottom. Technically the x here doesn't have a variable, or sorry, an exponent. So technically I can write a 1 in here. So we have 4 minus 1, which is going to be 3. So up top I'm going to write x to the 3rd. And then here I have 2 minus 2, which is going to give me 0. So since that cancels out completely, I'm not going to write y to the 0 or anything like that. I'm just going to leave it. So my answer here is going to be 5x to the 3rd power. Really quickly, I want to show you guys how you could have also expanded this out to solve. If we had expanded this out, it would have been 75x, 4 of those, and then 2 y's. Down at the bottom, we would have had 15, 1x, and then 2 y's. We would have had that. This step stays the same. 75 divided by 5, or 15, sorry, is 5. X, I would cancel one of these out. I would be left with 3 on top, which we would write as x to the 3rd. And then my y's, that one would cancel, that one would cancel. They both go away. Or they both technically reduce to 1 is what we would technically say. And since they both reduce to 1, then we're not left with anything, which again gives us the exact same solution. All right, number 7. Which expression is equivalent to 3x squared to the 3rd power and then x to the 6th to the half power? So we haven't really talked about half powers, but really quickly we'll just kind of cover that as we go. So basically what you have to know about exponents or expressions is this part here. The exponents on the outside, we have to do those first, and then we can combine our other exponents. So first thing I have to do is write this in here 3 times. So there it is, 3x squared, 3x squared, 3x squared. And then, even though we haven't really talked about half, think about if you had to write this half time or halfway. So instead of writing x to the 6th all the way, I'm only going to write half of them, which would technically be x to the 3. You can also think about this as your rule, exponent. So this would be a power to power rule, which if you have your little flip chart, you would go to power to a power. And that says that you keep your base and you multiply your exponents. You can also do 6 times 1/2, which 6 times 1/2 is going to be 3. So there's my expression. That's what I'm multiplying together. So I'm multiplying 3x squared times 3x squared times 3x squared times x to the 3rd. And so same thing as before, kind of the general rule of this is always to multiply your coefficients first. So we do 3 times 3 times 3. In other words, you multiply your big numbers. So 3 times 3 is 9. 9 times 3 is 27. Okay, so already I get 27. I can go over here and I can cross off A and B simply because they stop at 3. Next, with my exponents, remember that whenever you're multiplying all these things across, you multiply your big numbers. The rules for that is still the same. It's still multiplication. But for exponents, when we multiply things together with exponents, that means that we add our exponents together. So I'm going to be adding my little numbers, which are going to be 2 times 2 plus 2 plus 2, which gives me a total of 6. And then 6 plus 3 gives me a total of 9. So we have x to the 9th power, which again we've talked about earlier. You can also expand these out, have 2x's there, 2x's there, 2x's there, and then 3x's here. And then all you really have to do is count 1, 2, 3, 4, 5, 6, 7, 8, 9, so that we have x to the 9th power, which is going to be answer choice D. Number 8 says the expression a to the negative 12 and then times a to the 5th is equivalent to a to the n. What is the value of n? So here they're just basically asking me if I were to combine these two and I get some number that we don't know, n in this case, what is the value of this n? So with this we just want to follow our rule. Our rule says that if we're going to multiply two things, or two exponents, or sorry, two variables that have exponents, we're going to multiply those. Then we're going to keep our base, so a is going to stay a, and then what we do is we add our terms together. So we're going to add negative 12 and 5, which again, if you type that into your calculator or if you do it in your head, negative 12 plus 5 is going to give me negative 7. So here we have a to the negative 7, which again they say is equivalent to a to the n, which means that in this case n has to be negative 7. All right, we'll do the next few on the next video, just because I want to talk about a few things on the next one. So we'll do 9 through maybe the end of this on the next video.